Hello, everyone, and welcome to the Securing Sources and Destinations Cribl Skills Session. My name is Julia Ferrante. I'm a Senior Customer Success Engineer here at Cribl, and I'm excited to talk to you today about how Cribl can play a part in securing your data in transit. For today's agenda, we'd like to cover architecture and concepts, so understanding Cribl Stream and the capabilities that are available for securing deployments. We're going to talk through a worked example, so walking through how to secure a push source together. And lastly, we will cover some troubleshooting tips and tricks that help show you where to get help after today's session. So first, let's talk about some architecture. What are our goals? So when it comes to data in motion, there are two main objectives that come to mind. The first is confidentiality of data, or in other words, information cannot be eavesdropped or exposed so unexpected parties can see it or access it. The second objective is integrity of data, meaning that information or data cannot be modified in transit, and you know when a data hits its destination that it has been unaltered. For those less familiar or new to Cribl Stream, here's a quick overview. This diagram shows a reference architecture for Cribl, with the syslog source being sent through Cribl Stream and onto various destinations. Within this architecture, there are multiple integrations where data is in motion and having security is needed. You can see here that source traffic, Cribl control plane traffic, and destination traffic are all called out. In this workshop, we're going to be focusing on sources and destination traffic specifically. Now for a quick recap on TLS. TLS is the industry standard for encryption of data, and it's generally speaking the simplest and most standardized way to encrypt data in transit. Some reasons to use TLS. Encrypting data in transit prevents eavesdropping. So in any Cribl deployment, logs, metrics, and events travel between sources, workers, and destinations. And without TLS, this data can be intercepted by attackers, leading to potential data leaks or compliance violations. And TLS ensures that data in transit is encrypted, making it unreadable to unauthorized parties. Next is verifying the identity of components, for example, sources and destinations. This means that when your Cribl worker receives data from a source, it can verify that the source is legitimate and not an imposter. Similarly, when forwarding data to a destination, TLS ensures that it's going to the correct endpoint. With TLS certificates in place, only trusted components can communicate securely within your Cribl environment. And then lastly, integrity to prevent tampering of data in transit. So encryption alone isn't enough. We also need to ensure that data hasn't been altered in transit. And TLS provides message integrity checks. So if any part of the data stream is modified, whether that's due to corruption or malicious intent, the connection will detect it and actually reject that tampered data. And then our last bullet here, TLS is also widely supported, and it's likely to be the simplest and most maintainable way to secure connectivity. If you want to know more, there's plenty of resources on the internet. This diagram is from okta.com, and it just shows the basics of establishing a TLS connection. This is just helpful in understanding what goes on behind the scenes, and especially it's useful with diagnosing issues. So you can see the client and server first establishing that TCP connection at the top, performing the TLS handshake and verifying the certificate, and then lastly, opening the door to send encrypted application data. For a quick recap on certificates, they are certifiably a great idea, and a certificate will contain many more fields than this, but just wanted to highlight some of the important ones here for this presentation. So you have your common name, which identifies the host name or service that the certificate is issued to. You have validity not before, which would be the start date of the certificate when it begins to be valid. You have validity not after, which would be the end date of that certificate or when the date that it's no longer valid after. And then you have public key, which is used by the sender to encrypt data. And again, awareness of these can be useful when troubleshooting issues, especially when it comes to certificates expiring or being out of date, etc. In this diagram, we are looking at a high-level security architecture when implementing TLS with Cribl Stream. The goal here is to understand how TLS fits into the flow of data from sources to destinations and how it works at a high level. Walking through this diagram here, first we have the worker group, which this is where sources and destinations are configured at the worker group level. And the first step would be to identify the source and destinations that you want to set up and create within that worker group. Left-hand side, we have our sources. We have two of them that are listed here. For example, HTTP and Kafka. HTTP is a push source, which means that the source is the client and Cribl Stream acts as the server. For this example, you can configure Cribl to require a client certificate if you want mutual TLS. And then below that, we have Kafka, which is an example of a pull source, in which case Cribl initiates that connection. So in that case, Cribl is the client and the source is the server. In this case as well, TLS settings are configured on the source connector inside Cribl. On top of that, we have our certificate authority, or CA for short. The CA is responsible for issuing and signing certificates used by all components. And for this, you can use an internal enterprise CA, you can use a publicly trusted CA, or even a self-signed CA for lab environments. It's worth noting too that in mutual TLS setups, both sides present a certificate signed by the CA, and that ensures that two-way trust. And then lastly, on the right side, we have destinations. These could be cloud services like Amazon S3, Splunk, Elastic, etc. And in most cases here, Cribl is acting as the client sending data out securely. So TLS is typically used to encrypt that connection, and you can configure Cribl to validate the destination certificate using the CA bundle. If mutual TLS is required, you can also configure a client certificate on the destination connector in Cribl. So that's a high-level overview of the security architecture and components. So now let's talk through an example of securing a push source together. So to secure a push source, in this case, we're going to reference Cribl HTTP. You would go to worker group security settings, create a new certificate, or you can use an existing one, configure a source with TLS and certificates, and then test the connectivity. Now that we've looked at the basic concepts in architecture, let's take a look at how we can configure this in practice. As just mentioned, the security settings for TLS are configured at a worker group level for sources and destinations. So in this case, again, you would navigate to Cribl Stream, to worker group, group settings, and you'll see the screen shown here on the far right. So let's take a look at adding a new certificate, which we can later use with a source. For sources which support TLS, for example, HTTP or TCP, it can be enabled when configuring the source. The screenshot shows within the Cribl HTTP source under TLS settings that we can choose to enable TLS. It is disabled by default, so this is something you need to enable. And it's worth noting that since this is a push source, HTTP, it lists as server side. From here, you can select a pre-configured certificate, which will then populate the required fields. And you can see on the right-hand side, Cribl Cloud Key and Cribl Cloud Cert are some of those required fields. Next, after completing the setup, you can test from Cribl Stream and confirm the setup was successful. This is a great way to troubleshoot your setup and just ensure that all of that data can flow successfully. Now let's talk through some troubleshooting tips and tricks because it doesn't always work, unfortunately. Nmap can be a helpful tool in troubleshooting and understanding which ports are open, getting a good view of your network topology, etc. So here's just an example nmap command that could be used in that troubleshooting and helping to better understand the network landscape. This open SSL command can be used to view the certificate chain. And what this does is it shows you that certificate chain and it gives you the opportunity to really check and validate a lot of those fields, such as the CN, confirm that the certificate has valid dates, and just ensure that all of those fields are correct in that certificate. Looking at logs is another good place to start with troubleshooting TLS. Logs can be found in the monitoring section, and here you can filter accordingly to narrow your search and even select a time range you need. Here we can see an example TLS validation error that could be caused by maybe a passphrase or malformed entries. Just an example of what that error might look like. Another example error here of where an endpoint is expecting a different TLS version. So the wrong TLS version is actually being used. Here we can see another example error of a self-signed certificate where the request failed. So just some different examples of what you might find as you're going through those logs. Another one here is an example of a bad certificate that's causing a TLS validation error. And this is where that OpenSSL command can really help with taking a look at that certificate chain and validating that all of those inputs are correct. So to boil the last several slides into a single pane here, there are some general suggestions and recommendations for troubleshooting common issues. And each of those issues might have its own symptoms and kind of show itself differently within your systems. And there are some different suggested resolutions and troubleshooting steps based on the issue and symptom type. Another thing to consider is authentication. And authentication ensures you're the correct system requesting or receiving that data. It's extremely important to get right with pull or collector sources in particular, and it's important to consult the docs since the exact mechanism will vary a little bit between providers. For push sources, you can use credentials to prevent or limit spam, and you can also consider allow listing origin points too. If you are interested in learning more about Cribl or continuing to develop your skills, or if you're just looking for additional help and guidance beyond this Cribl skills session, there are several free resources which are available to you. First of which is our Cribl University. This is Cribl's online free training program. We have several courses that are out there. Cribl Certified User is a great one to begin with. It's the initial introduction course to Cribl. Beyond that, we have our Cribl Certified Admin courses. We have one for Stream and one for Edge, which give really great deep dives into each of those products, Stream and Edge, if you're looking to learn more about them and really start to become that engineer architect that's certified in those products. We also have our Cribl community and our knowledge base, in particular, knowledge.cribl.io, which has all of our different blog posts, YouTube videos, any sort of additional knowledge docs that are available for our products. And then we also have our upcoming events and workshops link. So if you enjoyed this Cribl skill session, there are a lot of other live learning options for you on different topics or for our different products as well. We have hands-on labs that are great resources if you're interested in learning more in this sort of live format. And then we also have our Slack community, which is a great resource again to join and communicate with other users of Cribl, bounce ideas off of each other, talk through use cases. And all of our Cribl employees are in there as well to help. And lastly, thank you for taking the time to listen to this session. I hope it was helpful and taught you something new about securing sources and destinations with Cribl. Have a great day and secure your data.